All right, let's take a look. We're doing chapter 3, and it's parallel lines and transversals. Well, one of those things you probably already know. Which one of those have you probably already know a little bit about? Parallel lines. And we might have even mentioned it once or twice in here. I think we did. Didn't we talk about parallel lines? Yeah, we said they're two lines that do what? Or don't do what? They don't intersect each other. Exactly right. So let's put a couple lines on here. But we're going to do a lot more with parallel lines than just knowing that they're just two lines that don't intersect each other. All right, so I'll tell you what. I'll do one like this. I'm not going to put the arrows on the end, but they should have arrows, right? They keep on going in both directions. I'm just not going to put them on there. I'm going to copy and paste. So if you know about copying and pasting, it's exactly, if I can grab that thing. Come on, where is it? There it goes. Okay. We'll put it about like right here. Okay. So everybody take a look at these two lines right here. I'll call it line L and line M. Okay. And that's how we can name lines, right? Remember we talked about that? Put little letters right next to it, lowercase letters. So I'll call this line L and line M. Now, in order to, I don't know if, I can't remember if we did this earlier when we talked about parallel lines, but in order to show on this picture right here, it's not much of a picture, it's just a couple lines, but this picture right here, in order to show that they're parallel to each other, do you remember doing this? I can't remember if we did this before or not. If I put like a little arrow there and a little arrow there, okay, and I'll tell you what, you know what, I said I was not going to put arrows on the ends of these, but I'm going to, just to show you the difference. All right, so those little arrows on the ends right there just means they're lines, and they keep going both directions. This little arrow right here and this one right here, it means that they're both parallel to each other. Does that make sense? Okay, if I put a little arrow somewhere in the middle, you could put it right in the middle. It's just somewhere between these two end arrows. If you put a little arrow here and one here, that means that these two lines are parallel to each other, which means they'll never touch each other. They'll never cross, they'll never intersect. Everybody got that? Technically, the definition is like two coplanar lines. What does it mean to be coplanar? It means they lie in the same plane, right, okay? So if these two lines lie in the same plane, which they do because they're on that flat surface of my screen right here, okay? If they lie in the same plane and they never intersect each other, then they're parallel. So in order, if I just said that they're parallel, and let's say it this way. If I just showed you on the picture that they're parallel, those little arrows right there, they don't have to be red. I just made them red just to make them stand out a little bit, all right? Here's another way that you could write it. You could say that line L and line M are parallel, but we have a symbol for that. I think we might have talked about the symbol for parallel. Did we when we talked about parallel lines? I don't know, but we're going to do it now. So if you just put two up and down lines like this, that means, what does this thing right here mean? If you saw that, what does that tell you? It tells you that line L is what? Parallel to line M. Does that make sense? All right, so that's pretty important, knowing that your lines are parallel, because what we're going to do today, you're going to have to know if your lines are parallel or not parallel. All right, so they have to tell you. You can't just assume that they're parallel to each other. So if I did this, if I just said, I'll just slant it just a little bit. If I did this, can you say that they're parallel to each other? We don't know. Exactly right. That's the point. We don't know. You can't say definitively that they're not parallel, but you can't say definitively that, what? They are parallel. You just don't know until they tell you. How could they tell you? We just went over it. You could put, oops, there goes my thing again. Every day does that. All right, let's try this one more time. Put an arrow here and an arrow here. Here's something else you could do. If I have two sets of parallel lines, like these right here and these right here, this has one arrow, this has one arrow, and so do these. So sometimes you might be confused. Well, which ones are parallel? How do I know that this one and this one are not parallel to each other? Well, I don't. That's got one arrow, that's got one arrow. That kind of means that they're parallel, but do they look parallel to each other? No, not at all. So if I wanted to distinguish between one set of parallel lines and another set of parallel lines, what I'm going to do is this. I'm going to put two sets of arrows. So what do you think that means? The ones with two sets of arrows are what? Parallel to each other, right? And the lines with, oops, there we go. And the lines with one set of arrows are parallel to each other. Does that make sense? So we're not always just going to put one. So if I have different different lines in here, and I want to know which ones are parallel. Well, the ones with one arrow are parallel to each other, and the ones with two arrows are parallel to each other. We good? And how would I write this? Right here. How would I write that they're parallel? I could say, excuse me, getting a little choked up. I'm so excited about this. So line A is what? Trent, don't need it. So I could say line A is parallel to line B. That's how we show it. That's the, what's the word? I don't know. It's just the notation. That's what I'm trying to think of. Okay, that's the notation. That's the way that we use. That's to show that they're parallel to each other. Everybody good so far with parallel lines? These little arrows right here, it means that line A and line B are parallel to each other. And it also means that they are not parallel to L and M, because L and M have one set of arrows, A and B have two set of arrows, so the ones with two set of arrows are parallel to each other. The ones with one set of arrows are not parallel to each other. We good with that? The symbol in the middle means parallel, right? Yeah, that's what we've been discussing here. But thanks for playing along. All right. So let's do this. What was the other thing about this lesson? Parallel lines and what? Transversals. Okay, transversals. So what in the world are we talking about when we talk about a transversal? Let's make it go a little bit of a different direction. Oops. All right, there we go. What if I had these two lines? Do I know that they're parallel to each other? I do not, because they don't have the little arrows in between them, okay? So I don't know for sure if they're parallel to each other. They look like they are, don't they? But that doesn't mean that they absolutely are, okay? Now, I kind of know they are because I copied and pasted, all right? But just looking at it, though, if you looked at it on a quiz or a test or a homework or something, if they didn't tell you that they're parallel, we cannot assume that they're parallel, okay? We have to be told. Everybody got that? It's very important that they tell us that they're parallel, because we're going to be doing some stuff with this in a little bit. So let's put this in a different color. And I'm going to draw a line that actually crosses those two parallel lines. Now, what do you think we call that yellow line? Nah, it does intersect. It's true, but we don't call it. What do you call it? A transversal, right? Because remember I showed you the title of this lesson, Parallel Lines and Transversals? This is a transversal. So what do you think a transversal does to two lines? It intersects both of those lines, exactly. Everybody see that? It intersects both of them. So it would intersect right here, and it would intersect right there. So the yellow one is called a transversal. And it's important you know what that means, because we're going to refer to two lines cut by a transversal quite a bit, especially in this lesson right now.
So are the lines of the transversals coming through parallel, or?
Well, the transversal line's definitely not parallel to the other lines. Why? Because they intersect. Remember, parallel lines, the whole definition of parallel lines is that they don't intersect. So the yellow one, the transversal's definitely not parallel to this. But we just said, these two white lines right here, are they parallel to each other? We don't know. We don't know. All right? So I could, let's do this. So you could have something like this. All right? And let's make this. All right? So these two lines, these two yellow ones, they obviously don't look parallel, right? But I still can't say it. I still can't say that they are or they're not. But even if you have two lines that are not parallel, this would still be considered the transversal. Which one's the transversal? The yellow ones or the white ones? The white one, okay? Because it crosses the other two lines. Now, these would eventually cross, wouldn't they? These two yellow ones? Yeah? So watch. What if I grab that and moved it here, and I grab this? See, eventually, they cross each other. So they're definitely not parallel, because parallel lines would never intersect each other. So this would still be the transversal. So a transversal doesn't just cut parallel lines, it cuts any lines. In fact, it could cut more than one line. So what if I had a line like this? Okay, I got three lines. What does that white line do? It crosses here, it intersects all three of those lines, doesn't it? Okay, so it's considered a transversal. Everybody with me on that? All right. Now, let me just take a look at the book, see if I'm missing anything. Oh, yeah, let's do this. So now we know what we know what lines are, and we know what parallel lines are, and we know what a transversal is. Now we're going to get into it just a little bit more. So I'm going to put two lines that definitely don't look parallel to each other, and I'm going to make another line. Let's change the color of that. Let's make it red, all right? And let's just make it go through right here. Which one is the transversal as far as the color of the lines? The red one is the transversal because it intersects both of those lines, okay? Now, what I'm going to do is I want to take a look at some of the angles that are formed by those lines, all right? Let's take a look. You see this angle right here? See that one? Okay. What I'm going to do is I'm going to number a whole bunch of these angles, all right? So write that. So write two lines, put a transversal. Pretend that there's arrows on the ends of these. I'm just not going to take the time to draw the arrows, but pretend they're lines and they have arrows on the ends. I'm going to call this angle 1, angle 2, angle 3, 4, 5, 6, 7, and 8. Okay? Everybody see that? I didn't have to start over here to call this angle 1. It's just what I decided to do. There's no rule or anything that says this one has to be angle 1. I could have started down here. I could have mixed them up. It doesn't matter. This is just how I decided to write it. Okay? Now, what we're going to do here is really, really important. Okay? We're going to name some of the relationships between some of these angles. You're like, what are you talking about? Well, let me help you out. Let's take a look at let's take a look at this first. See this clump of 4 angles up here? And you also have a clump of 4 angles down here. You got it? So what I'm going to do is I'm going to compare some of the angles up in this clump, all right, or this group of angles, and I'm going to compare it to a group down here, okay, to an angle down here in this group. So let's take a look at angle 1. When I look at angle 1, I'm looking at it as it's in the top left of that group of 4, isn't it? So let's go down here. What do you think? Which one is also on the top left of the group of 4 angles down here? 5. So angle 1 and, I didn't put equals, okay? All right? I will in a few minutes, but not right now. Angle 1 and angle what? 5. They match up, don't they? Okay? So they match up. We have a word, and we say that they correspond to each other. Very good. They correspond to each other, or we call them corresponding angles. Corresponding, and I'll just shorten angles like that, okay? So 1 and 5 are corresponding angles because 1's in the top left, 5's in the top left. Let's do some more corresponding angles. Let's find some other angles that are corresponding to each other. Let's go to angle 2. So what angle down here is corresponding to angle 2? 6 is, because 2 is in the top right, 6 is in the top right. Everybody see that? So I'm going to add that to my list. So angle 2 and angle 6 are what? They're corresponding angles. So all these I'm listing right now are under the umbrella of corresponding angles. There's a couple more, aren't there? What do you think? Let's go to angle 3. So angle 3 and angle 7 would be corresponding. All right, so let's write that down. Angle 3 and angle 7 would be corresponding. And there's one more set. What's the other set? That's right, angle 4 and angle 8. So angle 4 and angle 8. It's really important that you see how they correspond to each other, right? How they match up, right? 1 is in the top left, 5 is in the top left. 4 is in the what? Bottom right, and 8 is in the bottom right. So they match up with each other. You see that? Now, if these lines aren't parallel, we don't know that angle 1 and angle 5 are equal or anything like that, okay? I'm just showing you what they are. They're corresponding angles, okay? Let me show you some other angles. And I'm just going to write down what they are, and then I'll show you this. So the next one is alternate, I'll talk about this in a second, interior angles. All right, so I'm going to list the pairs. There's only 2 pairs. Okay, there's 2 pairs of alternate interior angles. Let's take a look at that word interior first. The interior means it's between these 2 yellow lines, okay? So there's 4 angles that are in between, inside, okay, those 2 yellow lines. What would they be? What would the 4 angles be? That's it. 3, 4, 5, and 6. Everybody see that? So if you got those two yellow lines, what angles are in between, inside of those two lines? 3, 4, 5, and 6 are. What would I call 1, 2, 7, and 8? Exterior angles, okay? So we actually have a list of, I'm going to shorten this a little bit. I'll just put alt. Is that all right? For alternate interior, and I'll shorten exterior to that. And then angles. So let's find out which ones are alternate. Now, alternate means, like if I say angle 3, alternate means it's on the complete opposite side, okay? But they got to be the interior. So I got 3, 4, 5, and 6. Which one is completely opposite of 3? Is it 4? Is it 5? Is it 6? It's 6. Because look, out of these 4, I'm sorry, 3, 4, 5, and 6, 3 is up here on the top left. This is down here on the bottom right. You see it? See how they're on the other side of the transversal? They're alternate sides of the transversal. And one's up here in this group, one's down here in this group. So they're really completely opposites, aren't they? Yeah. Okay, you see it? So they would be considered what? Alternate. No, they're not exterior. They're in between the two lines. So they would be alternate interior angles. So I'm going to write that down. Angle 3 and what's the other one? Angle 6. Do you see another pair of alternate interior angles? 4 and 5. Okay, let's write that down. So 4 and 5 would also be alternate interior angles. Well, why did I put 5? Doesn't matter. I could have just put 4 there. So what did I say? 4 and 5, right? So 4 and 5. So they would be alternate interior angles. We're going to have a quiz on this eventually, right? And one of the questions on the quiz is going to be this. It's going to be, it might say something about what are angles 3 and 6 to each other? What's the relationship between angles 3 and 6? And you would tell me they're alternate interior angles. I could ask you, what's the relationship between angle 1 and angle 5? What would you tell me on 1 and 5? What are they to each other? 1 and 5. No, they're not parallel. Angles can't be parallel. Only lines can be parallel. 1 and 5, they're corresponding right here. It's right in front of you, right? It's in your notes. They're corresponding. What about 4 and 8? 4 and 8 are what to each other? They're corresponding. 4 and 5, what are they to each other? Alternate interior angles. Yep. Alternate interior angles. Okay, 3 and 6 are alternate interior angles. Would you be able to do that if I gave you a list of the angles and you tell me which one's which? Okay, I might do that on a quiz. All right, so make sure that you know what the names are. Now, we know what the alternate interior angles are. Let's take a look at the alternate exterior angles. It's really not much more difficult. Let me get rid of those circles right there. So which ones are the ones on the outside of the two yellow lines? Well, 1 and 2 are outside the yellow lines, and 7 and 8, right, are on the outside of those yellow lines right there. Now, which ones are alternate? Angle 1 and 8. See how 1 is on the left-hand side, 8 is on the right-hand side. 1 is above, right, in that group of 4. 8 is below, right, that group. So that means they're alternate, all right? They're complete opposites, but they're exterior angles. So let's write that down. So what? Angle 1. And what's the other alternate exterior angle with that? Angle 8, okay? You got one more set. What would that be? What's the other exterior angles? 2 and 7. That's right. So let's write that down. Angle 2 and angle 7. Everybody got that? Okay. Now, why in the world do we need to know these? Well, I'm glad you asked, because I'm going to show you right now. Now, there's another set that we're going to learn, but I think I'm going to just pause a little bit on that and do something else here. So I'll tell you what, let's keep that same color coordination here. So watch what I'm going to do. Instead of just any old two lines, what kind of lines do you think I'm going to put now? I'm going to put parallel lines, okay? So these, now I don't know they're parallel just yet, do I? Right, because you don't have the little arrow thingy on there, all right? And I'm going to do this. Let's raise this up a little bit. And I'm going to do this. Boom, boom, okay? It's kind of the same thing as we just did before. Let me move this over, scooch this over just a little bit. And I'm going to name them the same exact numbers. Remember, I could name them anything. I don't have to name this angle 1. I could have named this angle 17 if I wanted to, okay? It makes no difference. But just to make it a little bit more, I don't know, easier for you, or consistent, more easy, more easier. 5, 6, yeah. Like these right here? Yeah. These right here, well, one's on one and one's on the other. So you got both. Oops, I'm stuck to my thing. One here and one. Yeah, you could have put it, if you wanted to, you could have put one over here or one over here, but you just pick. Yeah, it doesn't matter. It's just got to be somewhere in there, all right? Remember, these arrows mean something different than the arrows on the end. The arrows on the end just means it keeps going. I'm just kind of lazy, and I just didn't put the arrows on the ends of these, okay? That's the only reason I did that. Now, what I want to show you is this. We have a thing called a theorem. Actually, yeah, these are theorems. I should have done the postulate first, but I'm going to do the theorems first. So we actually have a thing called let's do the corresponding first. That's actually a postulate. It's called the corresponding angles postulate. Do you remember one of the very first days in here, we talked about the difference between a postulate and a theorem? A postulate you just accept as fact, but a theorem you have to prove, okay? Don't worry, we're not going to prove anything in here, okay? So basically, to you, they're all going to look the same. But here's what the corresponding angles theorem says, that when you have let's say it this way. When you have two parallel lines cut by a transversal, when they say cut, it means it intersects, okay? Two parallel lines cut by a transversal, then all this stuff is true. Do we have two parallel lines cut by a transversal here? Absolutely. There's my two parallel lines. There's my transversal. What the corresponding angles postulate says is that all the corresponding angles are equal to each other. They're exactly the same. So earlier, we picked out which ones are corresponding, didn't we? But now, if you have parallel lines, and this only works if you have parallel lines, like the thing that we did up here, these lines were not parallel, so it didn't work here. But we know which ones are corresponding angles, so now what we're going to say is that the corresponding angles, according to this postulate, are equal to each other. So let's write them down. So angle 1, I'm not going to put an and in between. I'm going to put a what? Equal sign. Angle 1 equals, what's corresponding to angle 1? Let's do it really quick now since we know these. Angle 1 and 5 would be actually equal to each other. So 1 and 5 would be exactly the same. So if I told you that angle 1 was 120 degrees, what would you tell me angle 5 would be? 120 degrees, just like that. Pretty simple, isn't it? Yeah. Okay. And then, yeah, let's list all the corresponding angles that are equal to each other. So angle 2 is going to equal what? Angle 6. Angle 3 is going to equal angle 7. And angle 4 is going to equal angle 8. That's really helpful because you have a feeling right now already what they're going to ask you on a quiz or a test, don't you? They're going to give you the situation. They're going to say angle 2 is 30 degrees. What is angle 8? All right? And you would say angle 8 is 30 degrees because 2 and 8, I'm sorry, I lied. 6, I meant 6, okay? If I said that 2 was 30 degrees, then what would angle 6 be equal to? That would be 30 degrees, right? Let's think for a second here. This isn't like officially part of this, but what if I gave you angle 2 was 30 degrees and I asked you to find angle 8? So if 2 is 30 degrees, then 6 is what? 30 degrees. But what if I asked you to find angle 8? By doing what? We've done this before. This is something that we've done before. So think about it. Everybody look up here and concentrate and think. If I told you angle 6 was 30 degrees, and I asked you to find what angle 8 was equal to. Do you remember doing this? Whoops. Watch. This might look more familiar to you. Okay. If I said that that was 30 degrees, what's this angle right here going to be? Why 150? It's not right. It's a straight line, right? Straight angle. So The whole straight angle is 180, but this part of it is 30, so what's this going to be? 150. Make sense? Now, look, let's translate that. We learned that before, right? We've done that before. I think I had a question on a quiz that was like that. Yeah. So now, let's think a little bit. It's slanted a little bit more than this. It's not, this isn't going straight across the bottom or anything. But look at this. If this is 30 degrees, angle 6, tell me what angle 8 is going to be. That's right, because it's that transversal is a straight line. It's 180 degrees. So if that's 30, this is what's left over, isn't it? According to that straight line. So if this is 30, then this is 150. Okay? Yeah, so exactly. So we would go 180 minus 30, and that's 150. And that's what this angle 8 would be if angle 6 was 30 degrees. That's the kind of stuff that they're going to ask you, okay? Some of them are really easy because some of them are equal to each other. And you just look at it and you say, oh, they're corresponding angles. Bang, they're equal, right? But they might say angle 2 is 30 degrees. Find what angle 8's equal to. So you could say, well, 2 is 30. That means 6 is 30, right? And then if this is 30, this has got to be 150. Or you could do it another way. You could say, if this is 30, what's angle 4 going to be? That's going to be 150. And what's true about 4 and 8? They're the same, so if this is 150, then this is 150. See how they all works together? Okay, let me try to erase all this mess. Get rid of that. Yes? Yes. Do you have your book? All right. So let's do another postulate. It's actually, I lied, it's not a postulate, it's a theorem. That's the only postulate. Remember, a postulate is accepted without proof, okay? It's just somebody told us, we got to believe it, all right? And that's what a postulate is. The next thing is a theorem. But it looks, to you, it's going to look just like that postulate. Let's just do it right here. It's called, guess what? The alternate interior angle. Is it angles or angle? It's probably angle, right? Theorem. And I'll just I'll just write it out since it's the first time. Now, what do you think this says? Alternate interior angles. Remember we did the alternate interior angles? We just showed which ones were alternate interior. We didn't really say anything about them, but now we can say something about them. Remember, 3 and 6 are alternate interior. 4 and 5 are alternate interior. This alternate interior angle theorem says this. If two lines are cut by transversal, do we have that situation? Yes. If two lines are cut by transversal, then the alternate interior angles are equal to each other. Okay? So what are the alternate interior angles? 3 and what else? 6. That's right. So they're not just alternate interior angles, but now we know that angle 3 is what? Equal to angle 6. Everybody got that? And then what else do we know on this? Angle 4 is equal to angle 5. Exactly right. Do you see the difference between what we did before? What we did before, we just identified them. That's all we did. We just said they're corresponding, they're alternate interior, they're alternate exterior. But now, with this postulate and theorem, now we know that they're actually equal to each other if you have two parallel lines cut by transversal. Okay? So if you have two parallel lines cut by transversal, then this stuff is true. Is it true when the two lines are not parallel? No, it's not. Okay? Even though 3 and 6 are still alternate interior angles, they're not equal to each other because these two yellow lines are not what? They're not parallel to each other. See the difference? So the only way that they're equal is if the two lines are parallel to each other. All right, we got one more set to do. I'm going to come back up here. We have this. I want to look at angle 3 and angle 5. All right? Now, they're interior angles, aren't they? Do you see that? But they're not alternate interior angles. Okay? We call these consecutive. Consecutive means one right after the other. Okay? Consecutive interior angles. All right? So this is 3 and 5. They're considered angle 3 and angle 5 would be consecutive. interior angles. I used to teach out of a book that called them same side interior angles. Why do you think they would call them same side? Because they're on the same side of the transversal. That's right. Okay. So, but this book and another book that I used to teach out of also calls them consecutive interior angles. So 3 and 5 would be consecutive interior. What's the other consecutive interior? 4 and 6. Okay. All right. So now we know which ones are consecutive interior angles. Let's go back to this. Let's take a look at 3 and 5. Do you think that our theorem, because we have a theorem and we call it the consecutive interior angle theorem. I'll just shorten theorem. Okay. Do you think that they're equal to each other, like the corresponding and the alternate interior ones? Look at 3 and 5. What kind of an angle is angle 3 right here? As far as less than 90, greater than 90, that kind of thing. What do you think? Right there. 3 and 5, 4 and 6. Okay. So 3 and 5 are consecutive interior angles, and 4 and 6 are consecutive interior angles. But the question is, are they equal to each other, like the other stuff was? Right? Not every single one of these angles are equal to each other. Would you agree? All right. Look at 3. What kind of an angle is angle 3? It's what? I didn't say that. I said not everything is equal to each other here. All right. So 3 and 5. Look at it. What kind of an angle is angle 3 as far as being less than 90, greater than 90? What kind of an angle is it? We've discussed this before. It's an acute angle. Remember doing that? Okay. So angle 3 is an acute angle, which means it's what? Less than 90. Look at angle 5, though. I'm going to put 2 arcs on here to show that it's not equal to this one. Angle 5 is obtuse. Is there any way that 3 and 5 are going to be equal to each other? Not in this situation. What if that transversal was perfectly straight up and down, though? Then they'd both be 90, and then they would be equal to each other, right? But what do you think might be true about angle 3 and 5, though? Let's kind of come up with our consecutive interior angle theorem on our own. Because 3 and 6 are equal to each other, correct? Do you agree? What's true about 5 and 6? They're not equal to each other. What are they? They add up to what? 180. They add up to 180. Did we talk about that word, the word supplementary? Did I use that in here? Okay, let's use that word. What? Supplementary. That means that they add up to be 180 degrees. Supplementary means the two angles add to be what? 180 degrees. Okay, that's what that word means right there. All right? So what's true about 5 and 6? They add up to 180, so they must be what kind of angles then? Supplementary angles. Okay, so supplementary angles add up to 180. Everybody watching me? I know it's warm in here. I know the time is getting close. We've been talking a long time. But hang with me here. Okay, look. 3 and 6 are equal, correct? 5 and 6 are supplementary. So what do you think might be true about 3 and 5? Because 3 and 6 are the same angle, right? So they're supplementary as well, aren't they? So what do you think this says? If two parallel lines cut by a transversal, then the consecutive interior angles are what? They're supplementary. So I could say that angle 3, I'm not going to put an equal sign here because they're not necessarily equal, and angle 5 are what? Supplementary. Again, no, I'll just shorthand it. Remember, you got to know that word. Supplementary means they add up to 180. All right? And what's the other consecutive interior angles? 4 and 6. Okay, so angle 4 and angle 6 are also supplementary. You know where students can really mess up on this? They think that 3 and 5 are what? Are equal. They're not equal. Okay? They're not equal. Unless that transversal goes straight up and down, they're both 90. But they're still supplementary, aren't they? If one's 90, the other one's 90, they still add up to 180. So the consecutive interior angles are always going to be supplementary. You got it? If you have two parallel lines cut by a transversal. That's a big if. Okay? What do you think? Does this start to make sense? Yeah, that's not too bad, is it? I mean, you learn some new words. All right, and I warned you at the beginning, the geometry is full of new words, okay? It's like a whole another language, all right? We learn consecutive interior, we learn alternate interior, we learn corresponding, we learned supplementary, right? We learned a lot of new stuff today. So you got to keep that straight. You got to keep it straight. All right, so that should be enough. There's also another one I forgot. I'm not going to write it down. There's also an alternate exterior angle theorem, okay? So what do you think is true about 1 and 8? They're equal to each other. And then what about 2 and 7? They're equal to each other as well, okay? I didn't write it down, just running out of time, okay? Do we have any questions? Any questions? I know we did a lot of stuff today, all right? But you guys were good. You paid attention. If you were sleeping, like a couple of you in here, I won't call you out, but I should. You could watch the video. But the way I look at it, if you're sleeping in class, you probably won't go back and watch the video anyway. So why do I even bother? I don't know. It absolutely is. Did you hear what Mackenzie said? Listen. Hey. Did you hear what she said? She said, the videos are really good because if I get confused in class, I can always go back, listen to it again, right? Watch it again, and then it starts coming back to me. Sometimes you might have to watch it a couple times. All right? So here we go. Homework. Wait till I do this. Yeah, this room is really hot. I apologize. There's nothing I can do about it. Anybody? Are you writing this down? Actually, it's not pages. It's just one page. There it is right there. There's your homework. Okay? I knew you guys couldn't stay quiet the whole class, but for half an hour or so, you guys did pretty well. All right. That's it. That's your homework.